Hey guys, how are you? Hope you all are doing very well. And here in this lecture, we are going to discuss about hardware and the software concepts of distributed systems. So it is our lecture 4 for distributed systems. And in our lecture 1, we have discussed about introduction of distributed system, characteristics of distributed system. In our lecture 2, we have discussed about various architectures of distributed systems. And in lecture 3, we have discussed on goals of distributed systems, and here we are discussing about hardware and software concepts. So the content of this lecture is like in hardware concepts we'll discuss about multiprocessor bus based systems and multiprocessor switched based systems, and in software concepts we will discuss about distributed operating systems and network operating systems and middleware operating systems. So let's start. So the first point here is hardware in distributed systems can be organized in several different ways, like shared memory. In shared memory, multiprocessors which have a single address space, and primary memory, that is multi-computer. Each CPU has a direct connection to its local memory. So if we see about hardware concepts in distributed system, you can easily see the shared memory is here and private memory is here, and here it is a bus based and switched based. So if you will look here, in shared based memory, various memories are attached in with the single bus system like this, and various processors are attached with this. So it is multiprocessor in which memory is shared in a bus based system. And if you will see here, private memory, you can see easily that with each processor memory is attached, with each processor memory is attached, with each processor memory is attached, right? So and further they are attached to a single bus. So this is bus based multiprocessor systems in which shared memory is one and the private memory is one. And if you will further see in the switched base means we have used the networking devices, that is switch here, and from this switch various processors are connected and various memories are shared with these processors. And similarly in switched base for private memory, in private memory basically memory is attached itself privately to each CPU computing device, that is processors, and in this manner it is called as a switched based private memory, and here it is called as switched based share memory. So these are four different kinds of hardware's processes for multiprocessors, right? So if we see some important points, that multiprocessor in bus base, they have limited scalability, means if further something want to add to it, then it would be get difficult, and cache memory help avoid bus overloading in this, right? So in a multiprocessor bus based, basically if new resources or new user want to add to it, it would be difficult because we have limited scalability in the bus based multiprocessor system. And if we go with the multiprocessor switch based, then in this case different CPUs can access different memories simultaneously, right? The number of switches limits the number of CPUs that can access memory simultaneously. And multiprocessor switch based, a crossbar switch, you can see here the processors are here and memories are here, and this crossbar switch, you can see this crossbar switch, and omega switch is like that, which is nothing but 2 cross 2 switch, two memories are attached here. Further from this switch again next two switch are attached, so it is called as 2 by 2 switch. From this various CPUs are connected with memories. So this is nothing but multiprocessor switch based architecture of the processors. And if we talk about multi-computer, till now we have talked about multi-processors. Many processors are working, many processors are working. And if you will see multi-computer, so it is also two type, homogeneous and heterogeneous. So if we talk about homogeneous, all CPUs and memories are identical in it. They are connected through a broadcast shared multi-access network like Ethernet in bus-based system, and the messages routed through an interconnection network in switched-based multi-computer. For example, grids, hypercubes. And if we talk about heterogeneous, then it is the most usual topology under the multi-computer systems. Computers may vary widely with respect to processor type, memory size, input-output bandwidth, and connections are also diverse. And a single multi-computer can simultaneously use local area network and wide area network and frame relay network and like that. And sophisticated software is needed to build applications due to inherent heterogeneity. Some examples are like World Wide Web, and they are example of multi-computers. Means multi-computer means you can see that computer system, different computer systems are there. They are working together. This is multi-computer hardware concepts in distributed systems. Whereas in a multiprocessor, various processors, various CPUs are working like that. This is the case, right? So this is the exact difference. And if we talk about software concepts now, then as in software concept, the software of the distributed system is simply selection of various operating system platforms. The operating system is the software for interaction between device users and its hardwares. There are three most important operating system types. The first one is distributed operating system. Next one is network operating system, and the next one is middleware operating system. So what they are, see here. In distributed operating system, if we talk in distributed operating system, a common set of services is shared among multiple processors in such a way that they are meant to execute a distributed application effectively and also provide services to separate independent computer connections in a single network. So if you'll see that the disadvantages of distributed operating systems are, it has a problem of scalability. It supports only limited number of independent computers with shared resources. If we will further add some more computers for some more resources, it would be not scalable up to that. And there is need to define message passing semantic prior to the execution of messages. Means to execute any messages, further messages, by default, by earlier we have to define message passing semantics to it. If we talk about software concepts here, you can simply see that in distributed system, different machines, machine A, machine B, and machine C is here, which is further connected to a network, and each machine has its own kernel, and all distributed operating systems are provided as a common services between among all of them, and further over it distributed applications are there, right? So this is the architecture for distributed operating systems under the software concepts. And if we see about the next topic, that is nothing but the network operating system. Network operating system, it is specifically designed for heterogeneous multi-computer systems where multiple hardwares and network platforms are supported. It has multiple operating systems running on different hardwares, multiple operating system running on different hardwares connected in network, and provides to each computer connected in network. The advantage of software concepts of network operating system is that it has a scalability feature. Means if you want to add further more resources to it, if you want to add further more users to it, it would be scalable up to that, right? And users are supported. Means you will add further users to it, it will support it. And disadvantage is that it fails to provide a single coherent view. In providing single coherent view, it gets difficult for network operating system. We'll see the architecture here. Architecture looks similar like a distributed operating system, but the difference is here that in distributed operating system, the distributed operating system services are provided among all of them as a common service, but here network operating system services are provided as a separate to each machine, machine A, machine B, for machine C, and for other machines as well. All networks operating system services will be provided as privately, and further distributed applications are shared between them as a common, as it is part of distributed systems, right? So it is the general structure of network operating systems. And if we talk about the middleware operating system, then it is a common set of services provided for the local applications and independent set of services for the remote applications, right? So remotely how you can operate the operating system services with on different computing devices and on different for different resources. So it supports heterogeneity, that it support multiple languages and operating system where user gets freedom to write the application using any of the supported language under any platform. And it provided the service such as locating the objects or interface by their names, finding the locations of objects, maintaining the quality of services, handling the protocol information, synchronization, concurrency, and security of objects. I hope all of you know that about it, that what is concurrency. Many resources are shared at a time, so how you can handle all that resources at a time, and how you will manage the security, how you will synchronize all the resources and all the items at the same time. So it's like that. So this is the simple architecture of the middleware services, middleware operating systems. It would look like that. Our networking operating system, these middleware services are added, and they will work common as a part of you can say the distributed operating system plus network operating system services. You can say that the hybrid model of that in one way, and it's the simple architecture of middleware operating system. So let's revise that what we have covered yet. If you will see here in this lecture, first we have discussed the topic multiprocessor bus systems. In a single bus is there, and with that bus, many processors in the private manner as well as in switched manner, as well as in distributed manner like this. In private manner and in shared memory system, they have attached. And after that, in multiprocessor switch bus also, we have seen here that in shared memory manner and in private memory manner, they have attached like that. And in software concept system basically consisted of three important operating system services: distributed operating system services, network operating system services, and middleware operating system services. Okay, so I hope that this session will be helpful for your upcoming semester exam or upcoming any competitive exam. And in our next lecture, that is lecture 5 and so on, one by one, we'll try to discuss about each and every area of distributed systems, like issues in designing distributed systems, right? And we'll also try to cover advantages, disadvantages, and much more on this. So do subscribe, guys. If you have any kind of doubt or query, do ask, and stay tuned with us. Thank you so much, guys. Have a very nice day. Jai Hind. Jai Bharat.